Hello friends, myself Dr. Nandakumar Raubale from College of Engineering Ambazubai is going to deal with fluid mechanics. So in previous class we have seen flow through siphon. Now in today's lecture we are going to discuss about power transmission through pipe, then condition for maximum transmission of power and maximum efficiency of transmission of power. So let us see what this power transmission through pipe is. So generally the power is transmitted through pipes by flowing water or other liquids which are flowing through the pipe. The power transmitted depends upon the two things, that is the weight of liquid flowing through the pipe and the total head available at the end of pipe. So here two things we have to see. First is weight of liquid, and second one is the power which is available or total head available at the end of pipe. At the end of pipe, these two things play very important role. So let us assume that there is one tank which consists of certain liquid filled in it up to the height h from the center of pipe. So this h is the energy input or power available, or the energy available at the inlet of this pipe, and as this liquid flows through this pipe there will be a friction between. Now let us consider this a tank wherein filled with liquid having the liquid level of height h at the inlet of this pipe, and as this liquid flows through this pipe there will be loss of head because of friction, that is hf. So amount of energy is lost because of friction here. So let us assume that the length of pipe bl, total length of pipe bl, and the diameter of pipe is d, whereas the total head available at the inlet of pipe is h meters, and the velocity of liquid flowing through this pipe is v meters per second, and hf is the head loss through this pipe, and f is the coefficient of friction. Now we'll analyze this system. So total head available at the outlet of pipe if minor losses are neglected. So here what happens, the head available at the outlet, so head available at the outlet of pipe is equal to, so total head at inlet minus loss of head due to friction. So here one assumption is made, assuming that there is no minor loss or neglecting minor losses, this we can write. So this head available at the outlet of pipe is obtained h minus of hf, where h is the head at inlet and hf is the head loss due to friction, or this can be written as h minus hf is 4 f l v square divided by 2g d. So this is the total head available at the outlet. So we call this as equation number 1, say. Now the power is depending on two factors. One is total head available at the end of pipe, and second one is the weight of liquid flowing through the pipe. So to find out weight of liquid flowing through the pipe, So generally what we find, weight is equal to if we know weight density into volume flow rate of water or flow rate of liquid. So volume flow rate of liquid is nothing but Q, that we call as a discharge Q. So weight density is nothing but rho into G, mass density into acceleration due to gravity, and this is volume flow of liquid, volume flow rate of liquid. So we call this as a Q. So Q is nothing but area into velocity. Q is equal to A into V. So this can be written as a rho G into pi by 4 d square into V. So now the power transmitted at the outlet of pipe can be obtained here. Power transmitted at the outlet of pipe which is equal to weight of liquid per second into head available at outlet, head at outlet. Therefore we know weight is equal to, so this equation number 2 gives a weight of liquid flowing through the pipe. So this is the weight is nothing but in Newton per second we can say. Then weight is given by rho G into pi by 4 d square V into head at outlet is given by equation number 1, that is H minus of 4 F L V square divided by 2GD. So this is we call as equation number 3, which gives us the power in watts. So equation number 3. Or else if we divide it by 1000, then this gives power transmitted in kilowatt. So this is equal to rho G divided by 1000. Dividing it by 1000, we convert this from watts to kilowatt, that is pi by 4 d square into V in bracket H minus 4 F L V square divided by 2GD in kilowatt. So this is equation number 4, gives us the power transmitted in kilowatt, or this can be written as rho G divided by 1000 into, so pi by 4 d square into V is Q in bracket H minus of, this is nothing but the head loss due to friction, we call this as HF. So this is equation number 5. So equation number 3, 4, 5 give us power transmitted at the outlet of pipe in kilowatt. So equation number 4 and 5 give us this power transmitted in kilowatt. So this is the simple or general equation for power transmission. Now we'll discuss about the efficiency of power transmission. So the efficiency of power transmission is given by the ratio of power available at outlet of pipe divided by power supplied at the inlet of pipe. So generally our efficiency is given by output divided by input. So the efficiency of power transmission that is given by power available at outlet of pipe to power supplied at the inlet of pipe. So therefore, power available at outlet we can call as, that is, weight into head. So weight per second, weight flow rate of water or weight flow rate of liquid, weight of liquid per second into head available at outlet. Whole divided by power supplied at inlet is weight of water or liquid, weight of liquid per second into head at inlet. Therefore, so head weight flow rate at outlet is W into head available at outlet is H minus HF whole divided by W into head available at inlet is H. So this can be written as H minus of HF divided by H into 100%. So this is the efficiency of power transmission for a fluid flowing through the pipe. Now let us see the condition for maximum transmission of power. So the condition for maximum transmission of power can be obtained by differentiating power with respect to the velocity. So the condition for maximum transmission of power is obtained by differentiating this equation for power that we have derived. So that is equation number, say, equation number 3, or we can call, say, equation number 4. So differentiating equation number 4, we get the condition for power transmission. So d of p, differentiation of power with respect to velocity, and equating it to 0, we get the condition. So therefore, differentiation of power with respect to v, so power equation was rho g divided by 1000 into pi by 4 d square into v in bracket h minus of 4 f l v square divided by 2gd. So this is equated to 0. So before differentiating, we will take this v in this inner bracket, rho g divided by 1000 into pi by 4 d square in bracket h into v minus 4 f l v to the power of 3 divided by 2gd. So multiplying this v with both the terms, we get this here hv and here v cube, equating it to 0. So while differentiating, this term rho g pi by 4 and d are treated as constant. So these are not going to vary. Therefore, the differentiation of this inner bracket, we have to find out. The differentiation of hv with respect to v is h minus 4 f l, differentiation of v cube is 3 into v square divided by 2g d is equal to 0. So now while obtaining this term, so we can transfer this, or h is equal to h is equal to 4FL. We can write this as v square into 3 divided by 2GD. So this term is nothing but the head loss due to friction. So this 3v square is written as only v square and 3 is taken outside. So here this h can be written as hf into 3, or head loss due to friction is equal to h divided by 3. So this is the condition for transmission of maximum power. That is nothing but when head loss due to friction is 1/3 of head at inlet, at that time the power transmitted can be the maximum. So maximum power can be transferred. So therefore the maximum power which we can transfer is maximum power, that is P is equal to rho g divided by 1000 into we can say this as pi by 4 d square v in bracket h minus hf is there. So now substituting hf is equal to h by 3, so maximum power, substituting h is equal to h by 3 in above equation, we can write this as maximum power is equal to rho g divided by 1000 into pi by 4 d square v h minus h by 3 means it is 2h by 3, 2 by 3h. So this can be written as rho g divided by 1000 pi by 4 d square v can be written as q into 2 by 3 into h. So this is the equation for maximum power that can be transferred. So we can write this as equation number, say this as equation number 5 or 6. Just we see, this is equation number 5. So this we write as equation number 6 for efficiency, and this we write equation number 7 for condition for maximum power transmission, and this is the equation number 8. So this equation number 8 gives us the maximum power to be transmitted in a pipe. Then we'll find this efficiency for maximum efficiency for transmission of power. So right now we have derived one equation for efficiency is equal to h minus of hf divided by h. So condition for maximum power transmission is hf is equal to h by 3. So substituting this in this above equation, so efficiency, maximum efficiency, we can say as h minus of h by 3 divided by h. So this is 2 by 3 h divided by h. So h gets cancelled, so that is 2 by 3, or this is into 100. If we multiply, then the maximum efficiency will be 66.66%. So maximum efficiency of power transmission through pipe is 66.66%. So now we will discuss a numerical over this maximum power transmission. So there is one pipe having diameter 300 mm and length, so diameter is given, length of pipe is 3005 meter, is used for transmission of power by water. The total head available at inlet, that is h, is given. Find the maximum power, so we have to find out P max available at the outlet of pipe if the value of f is 0.006. So now we will take out this data. Now you can see here diameter of pipe is 0.3 meter, head available at inlet is 500 meter, and length of pipe is 3500, and coefficient of friction is 0.005. So we have to find out Pmax. So generally we know that the equation for power transmission P is equal to rho g q h minus hf divided by 1000, or just now we have derived one equation for maximum power, that is rho g into q into 2 by 3 ph. So this formula can also be used. So this, instead of this, we can use another formula, that is rho g divided by 1000 into q into 2 by 3 EH. So this can also be used. So now what we need in this is, we know rho, we know g, we know h, we want q. So q is required. To find out q, q is equal to a into v. So this, if we use this first formula, then we need to substitute hf is equal to h by 3. Now we can find out hf because we know h. H value is given, that is head at inlet is known, that is 500. So we can find out hf. So once we know hf, to find out q, we need area and velocity. So here we have to substitute q in first equation. Therefore we have to find out q. Area we can obtain because we know diameter, but to find out velocity we have to use this equation for coefficient head loss due to friction. Hf is equal to 4FLV square divided by 2GD, because hf we can obtain from this equation h by 3. Hf is equal to h by 3, and 4 we know, which is constant. F is given, length of pipe is given, 2 is constant, g is known, diameter of pipe is known, only velocity is unknown. So from this equation we can find out velocity, and that velocity can be substituted in this equation. We can get q, and this q value we can substitute in first equation to get maximum power to be transmitted. So let us start to solve this problem. Very first we have to find out hf, head loss due to friction. Hf is equal to h by 3 for, this is condition for maximum power transmission. Which is known to us. So hf is equal to, h value we know, that is 500 meter. So 500 divided by 3 means this is going to be 166.7 meter. So now second thing we know is formula for hf is equal to 4FLV square divided by 2GD. So first we have to find out velocity, then we can find out q. So now hf value is 166.7, which is equal to 4 into f value is 0.005 into L value we know here is 3500, which is given 3500 into V square divided by 2 into G is 9.81 into diameter of pipe is given as 0.3 meter. So 0.3 meter. So from this, on simplification, we get V is equal to 3.417 meters per second. So we can obtain velocity from this. So first we obtained hf, then from that hf we obtained v. Now we can obtain q. So before obtaining q, we can find out area of cross section of pipe, that is equal to pi by 4 into d square. So pi by 4 into diameter of pipe is 0.3 square. So this is equal to area we can get as So area is 0.0706. So area we get 0.0706 meter square. So we know area. So now we can find out discharge. Q is equal to area into velocity. We know area. So area is given, or that we have obtained, is 0.0706 into velocity, which we have obtained now is 3.417 meters per second. So if we simplify this, we get Q is equal to 0.2415 meter cube per second. So this is discharge we have obtained. So now to find out power, P is equal to, so we have equation rho g divided by 1000 into Q into 2 by 3 into EH. So rho value for water is 1000 into G value is 9.81 divided by 1000 into Q value is 0.2415 into 2 divided by 3 into H value, which we know is given in this problem, is 500 meters. So we substitute here 500 meter. So this is power, maximum power. We are going to find out maximum power, P max. So by simplifying this, we get as 689.7 kilowatt power is transmitted. So this is one problem where the head is given in terms of meters of water. So next we will see where the head is given in terms of Newton per meter square or Newton per centimeter square. Now we see another problem. A pipeline of length 2000 meters. So length is given, L is equal to 2000 meters, used for power transmission. If 110.3625 kilowatt of power, so power is given, so this is P. So this is not a maximum power, it is a power. So power is to be transmitted through a pipe in which water is having pressure. So pressure inlet, P in, inlet pressure is given in terms of Newton per centimeter square instead of capital H. So now instead of capital H, pressure at inlet is given, is flowing. Find the diameter of pipe. So we have to find out D. Diameter of pipe is required to be obtained, and efficiency of transmission. So efficiency also we have to find out. If the pressure drop, so delta P instead of HF, head loss due to friction, there is a loss in the pressure is given in terms of Newton per centimeter square. So the pressure drop over the length of pipe is 98.1 Newton per centimeter square, and coefficient of friction F is given. So we will see how to simplify this problem. So in this problem, length of pipe is given, so power to be transmitted is given, that is 110.3625 kilowatt. So pressure at inlet is given as 490.5 Newton per centimeter square. So when we want to convert this from Newton per centimeter square to Newton per meter square, we have to multiply this by 10 to the power of 4, and the pressure drop, that is delta P instead of HF. So actually HF is required and here H is required. So instead of H, pressure at inlet is given, and instead of head loss due to friction, delta P is given in terms of Newton per centimeter square, that is 98.1 Newton per centimeter square. We convert it from Newton per centimeter square to Newton per meter square, multiplying it by 10 to the power of 4, and where coefficient of friction which is given is 0.0065. So 0.0065. So he is asking us to find out diameter and efficiency. Now we want to find out diameter. So to find out diameter, so where this diameter can be obtained, we see here. So HF is equal to 4FLV square divided by 2GD. So diameter is available in this equation. Once this HF is given, so indirectly this HF is given here, So in place of HF, delta P is given. So this delta P can be converted into HF. So how to convert this HF delta P into HF is delta P divided by rho g. So this is pressure in Newton per centimeter square. If we divide it by rho g, then we get head loss due to friction in meters of water. So head at the inlet is given in terms of pressure that can be converted into head in meters. So pressure at inlet divided by rho g gives us head at the inlet in meters of water. So these two equations help us to convert this pressure at inlet in terms of head in meters of water at inlet and head loss due to friction in meters of water. So these two terms we can convert using this. Then once we know HF, so we can substitute HF in this first equation, and F is known, L is known, G is known. Then we will get velocity in terms of diameter. So velocity we will get in terms of diameter. So when we get velocity in terms of diameter, we can substitute this velocity in terms of diameter in this equation. So we get here Q in terms of again diameter, because area is given in terms of diameter, velocity is given in terms of diameter. So here what we get is HF in velocity in terms of diameter from first equation, and in second equation Q in terms of velocity. Then in third equation, or this is second equation and now this is third equation. So when we come to this third equation, there we can substitute this rho g Q in terms of diameter, H minus HF. So H and HF already we have obtained using these two equations, that is equation number 4 and 5. So using equation number 4 and 5, we have converted this pressure in terms of meters of water. Then we get this here, and pressure, so power is given in this problem. So power is known, rho is known, G is known, Q is known in terms of diameter, H is known, and HF is known. So only diameter will be unknown that we can obtain. So while solving this problem, we have to convert this pressure which is given in Newton per meter square in head in meters of water column. So that we have seen static pressure H is equal to, sorry, P is equal to rho g H. So that is nothing but H is equal to P divided by rho g. So this is the formula which we are using here. Simply this pressure converted in terms of Newton per meter square when we know the head. So if we know head, static head, then that can be converted in terms of pressure in Newton per meter square using this equation, P is equal to rho g H. So H is equal to P divided by rho g. This same formula we are going to use here. So now H is equal to P in divided by rho g. So head at inlet, we can call this as head at inlet. So P in is pressure at inlet is 490.5 into 10 to the power of 4 divided by 1000 into 9.81. So this gives us head as 500 meter. This is 500 meters of head of water at inlet. So H inlet we know. Now HF is equal to delta P divided by rho g. So head loss due to friction is nothing but the drop in pressure divided by rho g. So drop in pressure which is given to us in this problem is 98.1 Newton per centimeter square. So 98.1 into 10 to the power of 4 divided by rho is 1000. Density of water into acceleration due to gravity is 9.81. So simplification, we get this HF as 100 meters. Now we know H and HF. So now we can find here, just we have seen one thing, that is we know h, we know hf. So we can find out hf or velocity in terms of diameter using first equation. Now coming to this first equation, hf is equal to 4f L p square divided by 2gd. So hf is given in terms of meters, that is 100. 100 is equal to 4 into f, coefficient of friction is given by 0.0065. 0.0065 into length of pipe, which is given here is 2000 meter. So 2000 meter into v square divided by 2 into 9.81 into diameter d. So here what we can get is velocity is equal to, or on this side if we see here, velocity divided by diameter. So just we see here 100 is equal to 4FL v square divided by 2GD. Just a minute. So here 100 is equal to, if we simplify these constant terms, this works out to be 2.65 v square divided by d. So we call this as equation say 1. So equation number 1 gives us this kind of result, that is 2.65 v square divided by d. So now from this q, discharge q, we can write as area into velocity. So now to know discharge, we have to use the first equation, that is power equation. P is equal to rho g q h minus hf divided by 1000. So here we don't know q, but we know power, we know rho, we know g, h and hf. So we can find out q from this. So power is known to us, that is 110.3625, which is given in the problem. So you can see here power transmitted is 110.3625 kilowatt. So this power is substituted here. Rho is 1000 into g is 9.81 into q and h is known, that is h is equal to 500 meter, which we have obtained, minus hf is 100 meter divided by 1000. So here we get q is equal to 0.02812 meter cube per second. So now here q is known. So from this equation q, we can substitute this q in this equation number 2 say, and this is equation number 3. So equation number 1 is nothing but 100 is equal to 2.65 v square divided by d. Now we'll substitute q in this equation number 2 and we get q is equal to area into velocity. So q is value is known, that is 0.02812. 0.02812 into is equal to, area is pi by 4 d square into v. So here diameter is not known, so we can get this in terms of velocity. So velocity v is equal to 4 into 0.02812 divided by pi d square. So if we simplify, v is equal to, we get this as 0.0358 divided by d square. So if we simplify these terms, constant terms, we get this as 0.03258 divided by d square. So we call this as equation number, say 4. We call this as equation number 4. So substituting this value of v from equation number 4 in this equation number 1. So what is equation number 1? Is 100 is equal to 2.65 v square divided by d. V square divided by d. So this is equation number, say, 1. So substituting this value of v in equation number 1, we get 100 is equal to 2.65 into, in place of v square we substitute this, so therefore 0.0358 divided by d square whole square. So this is in place of v square, and into denominator d is 1 divided by d. So on simplification, this is 100 is equal to 2.65 divided by d into, so this square is written here, that is, or directly we simplify this. So this constant term into square of this term, we get this as 0.03396 divided by d to the power of 4 into d. So this can be written as 0.00396 divided by d to the power of 5. So on simplification by this equation, so that is 100 is equal to 0.0033396 divided by d to the power of 5, or d to the power of 5 is equal to 0.03396 divided by 100. So or d is equal to, so this dividing 100, dividing it by 100, that is, it will be 0.03396 divided by 100 to the power of 1 by 5. So we get here diameter d is equal to 0.1277 meters, or diameter we can write as 127.7 mm is the diameter of pipe through which this liquid is flowing. Now next thing is left with us is efficiency is equal to H minus of HF divided by H. So we know H is equal to 500 which we have obtained, and HF is 100. So this divided by 500 into 100. So this will be the efficiency of power transmission. So here we can see H we have obtained as 500 and H is equal to 100 meters. So these values we have substituted here. So 400 divided by 500 into 100 we can say. So this efficiency is 4 by 5, means this will be 80% is the efficiency of power transmission. So we get here efficiency. So how this numerical is different from previous numerical is only the pressure which is given in terms of Newton per meter square or Newton per centimeter square, that we have to convert in head H, that is in meters of water. So rest of the things are very similar to the first problem. So this is how we have discussed about power transmission through the pipe. So we stop here. In next class we'll see the water hammer. Thank you.